Welcome to another video, just a series of videos where I'm going to try and distill mathematical techniques within A-level maths so that students can apply the techniques with confidence and just show their full working for the examiner. So one of the issues that I run into when students initially come across equations of straight lines, or they're asked to find equations of tangents and normals, is a lack of clarity around how do we find those equations. And whenever I've been teaching A-level maths for the last decade or so, I always fixate upon a checklist. So what things do we need for the equation of a straight line? Now, when you were taught GCSE, you were taught about y equals mx plus c. And you probably need a gradient, a y-intercept, and all this sort of stuff. But I advocate something different, but it's not actually very different or radical. But this is my checklist. Every time you're asked a question, find the equation of a straight line, find the equation of a tangent or a normal to a curve, which are straight lines. Then just focus on this. Do I have the gradient at that point? Do I have an x value which is related to a point that is relevant to me? And do I have a y value? If I have these three things, then I'm going to use this formula here, which is going to basically get me to the equation of the straight line. This is my checklist. So from now on, every time you've got a straight lines question, anything like that, keep that in mind. Have I got these three things here? So a really quick one here, I've got these two coordinates. I want to find the equation of the straight line between them. Now, what have I got? I have definitely got an x value. I could choose 1, and I can choose the corresponding y value of 2. So I've got x and y, but I do not have a gradient. Now, this is just two coordinates in the sort of axes. So to find the gradient, I'm going to do y2 minus y1 over x2 minus x1. Please don't get that formula wrong, otherwise it's going to go badly for you. So I'm going to take y2 to be this, y1 here, x1 here, x2 here. Okay, so y2 minus y1, 5 minus 2 over 7 minus 1, so 3 over 6, which is a half. So I've now got my gradient. That's great. I can tick that off. My checklist is complete. So I'm now going to get the equation of my line. So y minus 2 equals a half x minus 1. That is the equation of the line. And I can expand the brackets to get into any which form I want. That's fine when you've got coordinates in space like this. What happens if you've got a really simple example of a tangent to the y equals x squared graph? Now this is a curve, you know, so if you think about it, y equals x squared looks like this. 3, 9 is going to be here somewhere, and we want the tangent there. The tangent's a straight line. Now the equation of the tangent, well, what do we know about that tangent? Well, we know the coordinates 3, 9, so that's x and y sorted. So as part of that checklist, those two things are done. We don't know the gradient of the tangent at that point. Well, hold on, the gradient of the tangent at that point is the same as the gradient of the curve at that point. So how do you find gradients of curves? dy dx. So 2x, now substitute x equals 3 in, and that will get you the gradient of the curve at that point. Sub x equals 3, you're going to get a gradient value of 6. Oh, I've got my gradient now, checklist, sorted, and I will change this to y minus 9 equals 6, x minus 3. That is the equation of my tangent. Now what would change if I wanted the equation of normal? I would change that gradient to minus a sixth if I wanted the normal. And the normal would be a line that cuts a 90-degree angle to the curve. So that's the overall theme here. Any questions around equations and straight lines, build up this checklist sort of skill and try and do that with tangents and normals down the line.